Hello friends, welcome to my channel. Myself Parag Jambulkar. In parallel computing or high performance computing, decomposition techniques are very much important. Here, decomposition word has a large meaning. Decomposition in the sense when you have a big task, we are dividing that task into the small tasks or subtasks. That thing is called as a decomposition. Now there are various techniques for decomposition. Out of that, these four techniques are important, called as recursive decomposition, data decomposition, exploratory decomposition, speculative decomposition. First two techniques are very much common, while third and fourth, that is exploratory and speculative decomposition, are specific to the problem. Out of these four techniques, first technique is the recursive decomposition. Already we have heard the word recursion. In many programming languages, we use this word recursion. Recursion means what? Calling the same function again and again, that is called as recursion. Here we are using this word for decomposition. It is used for those problems which can be solved by divide and conquer method. When we have a big problem, we divide that problem into the sub problems, and these sub problems are independent. These problems are not dependent on each other, and again we recursively divide this problem into the sub problems. Again, these are not related with each other, are dependent on each other, until we get the atomic sub problems which cannot be divided again, and then we combine the results and we get the final outcome. That is called as a recursive decomposition. Best example is quicksort. In quicksort, we have a set of elements. Out of that, one element we choose as a pivot element. So we can choose first element as a pivot element, we can choose last element as a pivot element, we can choose random number as a pivot element. Any number you can choose as a pivot element. So in this example, we have taken last element as a pivot element. When we take this pivot element, we divide this problem into the two parts. So in this case, we have taken 9 as a pivot element. So all the elements those are smaller than 9, and all the elements which are larger than 9 along with 9, it becomes another part. Then in this example, we have taken 7 as a pivot element. So all the elements those are smaller than 7 on this side, and 7 along with the elements which are larger than 7 on this side. Here 6 is taken as a pivot element, so we got 5 and 6. Here 8 we have taken as a pivot element, 7 and 8. Here we have taken 10 as a pivot element, so 9 is lesser than 10, while all 11, 12 are larger than 10. So this is on another side. Here we have taken 11 as a pivot element, so 10 we got. On this side we have 11 and 12, and at the end 11 and 12. So in this way, we use quicksort to divide these numbers into the different sets, and finally we combine these results. So after, at the end, all the elements get sorted. Now this diagram is called as a task dependency graph. Task in the sense each subproblem is called as a task. Dependency graph in the sense dependency graph is a directed acyclic graph. Acyclic graph means there is no cycle and there is a direction. Direction is for combining the result. So recursive decomposition in the sense recursively we decompose the problem into the sub-problems, those are independent, and we recursively keep on decomposing and then we combine their results. That is called as a recursive decomposition. Now we see data decomposition. From the name you will come to know we are decomposing a data. Now see, best example is this matrices multiplication. So we are multiplying these two matrices. So this is a first matrix multiplying with the second matrix and we got this result. So these cells are C1, C2, C3, C4. Now see, C1 means what? This. C2 means what? This. C3 and C4 like this. Now see, C1, C2, C3, C4, this forms the data of this resultant matrix. Now what we are doing? We are giving C1 to compute C1, we are allocating it to one processor, To compute C2, we are allocating to one processor. To compute C3, we are allocating it to the third processor, and same thing C4 we are allocating to fourth processor. So here you will observe operations are same. Here you are multiplying, here also you are multiplying, then you are adding it. Same operations are here for all these. Where is the change? Only data. So here we have divided the final output based on the data. That's why it is called as a data decomposition. Next technique for decomposition is exploratory decomposition. Best example for this is puzzle problem, where initial state is given and we have to find out goal state. Here we divide a search space and each time we check whether we got goal state or not. So for example, here we can move upwards and or we can move leftwards. And again at the same time we are checking whether we got the goal state or not. So here we are decomposing, at the same time we are solving the problem. That is called as exploratory decomposition. Next decomposition technique is speculative decomposition. Here we choose the branch of computation based on previous output, just like switch case. In switch case we have an expression and based on the output of that expression we choose particular case. In same way we have the previous output and based on the previous output we choose which computation should be done. Again same thing, based on previous output we choose which computation should be done. That is called as speculative decomposition. There is one more decomposition technique that is called as a hybrid decomposition technique. If we combine multiple decomposition technique together, then that is called as hybrid decomposition. So in this way we have multiple decomposition techniques. So friends, I hope you like this video. If yes, then click on like, subscribe to the channel and don't forget to press bell icon so that you will get notifications of my next video. So stay connected. Thank you.